and just in the interest of time, set up a couple other things that we're going to need. But I didn't, I guess, include the name of it. I just want to make sure I use the same name because it takes a while to create the React app. All right, so we're just going to start completely from scratch and make our directory there. And the first thing we want to do is run npm init. That's going to ask us just a series of questions to create our package.json. So the package name defaults to the directory you're in. I always like to start with a 0.something version before we're really ready. Test module. Entry point is going to be the file that's actually loaded whenever somebody includes our module. We'll go with the default for now, index.js. Not going to worry about that. I did go ahead and create a repository for this, and I will try to commit along the way, and if I forget, call me out on it. Keywords we don't need, author if you want. And then the last thing it's going to ask is license. So it defaults to ISC, which is a very permissive open source license. Basically says anybody who gets a hold of this code can do whatever they want with it. They can cut and paste parts out of it, modify it, and not have to credit you. That's perfectly fine for open source stuff, but I just wanted to touch on that in a corporate environment. A lot of the time you have proprietary stuff that you don't really want other people to be able to use, and the convention for that is to just call that unlicensed. So now nobody is legally allowed to do anything with this code if they do happen to get a hold of it. So what that did was create us our package.json file. I am. So yeah, I pretty much just filled it in with the stuff that we did there. One other thing I wanted to do is, since we often in corporate environments are using a private repository for publishing, there is a section, let me move this down here, called publish config that goes in here. And all that's saying is, where would you like to publish this module when we actually go to push it up? It defaults to the public npm.js, which you don't want to accidentally publish that out. For this demo, I'm just using a little local repository, but this would generally be Artifactory or Nexus or something like that. So we add that in there, and then I thought I already did it in there. Never mind. And we're going to make an npm.rc file that goes in the project here, which also points to that, so that anybody else who checks out our code will have that same one. If you do the npm config, it's going to go in your home directory and not be checked in. So this way, the project itself specifies where it comes from. And that's pretty much all we need there to get us off the ground. And then the entry point that it started with here is this index.js file. So we're going to create that now. And since we're back in time, we're going to use as old syntax as we know how. So plain old functions and just something silly for our example here. All right, so the common JS format for imports and exports, so you're going to include stuff with require, which we'll do in just a second. And when you're exporting stuff, you are using this module.exports object. So we will just create an object with say hello in it. So that's saying that our whole library it consists of this index file, and all it's exporting is this one function. So we will go ahead and publish our very first version of this, and it packages that up and puts it in this case in my local repository. So over here in just a really bare bones app here that has nothing in it. Oops. Ah, yes. Not familiar with that one, but all right. So in that project, then we are just going to npm install, or npm I for short, and we called it walkthrough module. Oh, well, I did call it walkthrough module, right? Oh, walkthrough library. Did the wrong thing. All right, that would help. Live demos always go flawlessly. So. Okay, so we have included that, and so our the app that's consuming our library now has one of its node modules being our walkthrough library. And it contains a package JSON, which is what we had in ours, plus some extra stuff that npm adds, just like a hash to make sure that it's not corrupted and stuff like that. And then the files itself. So in this case, it is just verbatim what we had on the other side. So we do our index here. We will say walkthrough library equals require walkthrough library. And console.log walkthrough library.say hello to Eric. And now if we run node on our index file, it's included our library and called that function and spits this stuff out to the console. So far so good. In the early days of NPM, that was pretty much all there was to it. So let me go ahead and all right, so we committed everything that we've got there. So most of us are pretty used to working with ES6 at this point, so we don't really use the module.export syntax or the require syntax very often. So over back in our library, let's go ahead and convert this to be a little bit more of a modern library. So we will say const say hello. Note that const and the arrow function syntax were both newer versions of JavaScript. They came in with ES5. And then string interpolation came in with ES6. So we'll use several of our newer features that we're all used to now. And say export, say hello, like this. So we'll go ahead and make our module now version 2 and publish it. Update our little node app to use the newer version here. NCU is just a little app that updates dependencies. And if we run it again, now we have a problem because Node is not aware of the export syntax, so it can't read our library and it can't be used. In general, you always want to be good stewards when we put stuff into the NPM repository. We really don't want projects that are pulling those in to have to compile them or adjust them or change any kind of thing. We should kind of package all that stuff up together. So first thing I want to touch on is a tool called Babel. So what Babel is a transpiler, which is a fancy word for something that takes one style of code and converts it into equivalent code in another style of code. It's probably the shortest way to explain that. So we're going to have just a couple of dependencies that we want to install here. So we're going to install this at Babel core and Babel env. A quick note on the at Babel syntax there. At Babel is using I guess it didn't like me pressing my arrows. Oh, yeah, sorry, I had a typo in there. It's called preset env. But the at babel slash syntax is kind of newer in NPM. It's what they call a scope. But what's nice about it is an author can take that scope and then everything published under that, is from the Babel team. So with Babel 6 and earlier, everything would be like Babel-core. But starting with 7 and moving on up, everything will be under at. So if there's ever an option, you want to go with the at slash version, unless there's not, and then the Babel dash would be that. Kind of the best and worst thing about NPM is that anybody can publish to any name that's not taken. So I right now could make babel dash whatever and publish it up there. But I could not publish anything under @babel. So just a way of saying that these are the official plugins. And we want to make sure we're not mixing and matching old and new. So we've installed those two there. And then in the interest of not typoing anything, I'm copy pasting a little simple configuration file for it here. So basically this is just defining the options for it. There's very little that we need to do here. So we have got, let's just start out with something even simpler than that and say all we're doing here is just adding a preset. I'm going to add this for this demonstration, but we won't need this. We're going to go through automating Babel in a minute, so we won't have to call it directly. But just for demo purposes here, I'm going to add the Babel CLI and make us a very quick little script here for building. I'll also do rimref, which is just a jokey name on rm-rf, but it's no, I messed up my file here. And Babel source index.js, and the output is going to be dist index.js. So let's install that rimref thing, and that way we can start compiling. One thing to note, since we're going to be compiling now, we've got index right here in the root. So let's make a new file, a new directory called source, and then another new directory called dist. So source will be our uncompiled stuff, and dist will be what we're actually going to distribute with our module. One thing that's also nice to do here is you can use this little files entry in your package to say we only want to publish stuff in dist, so that way we're not publishing our source and our config files and anything else that happens to be stuck in our project. So we're saying we really only want to publish dist. So source is just our source code. This is what we're actually writing. And dist is going to be what Babel converts it to. Let me go ahead and do that, and we'll kind of compare the two of those things. So npm run build. I'm sure I didn't mess this up. Babel CLI, that did work, didn't it? Maybe it didn't, it's not here. So I guess I still had my typo in there when I tried to do that one too. Come on, node modules. All right, so we're going to run build and told it to compile source index and spit it out to dist index. So back to our first index file in source, and our other index file here in dist. So what Babel did was took our nice new ES6 syntax, our nice arrow functions, our nice string interpolation, and converted them all into older style stuff. So var instead of const, function keyword, and concatenation for the string. The reason for this is just I guess I forgot to mention, it really rose to prominence with ES6, but developers wanted to use ES6, but you couldn't force your users to update their browsers. So the whole point in transpiling here is to get it back to the oldest style so that older browsers can still run your code. Kind of an important thing, but it also exports it in this CommonJS kind of export syntax that Node can read. So now, if we publish our version 3 now, no, I don't really think so, to be honest. You're always going to have the language preceding what users have in their environment. And as we'll touch on a little bit later, it also allows you to add some other kinds of conversions from one kind of code to another that aren't even necessarily part of the JavaScript language. Most notably, what we use is React JSX. JSX is not valid JavaScript, so Babel has a plugin that's going to convert that into JavaScript objects. We'll look at that in a minute. There's also, we're actually using a lot of experimental features that have not been made part of the language yet, but will soon. And we can use Babel to allow us to go ahead and do those too. So now, I did one thing. Since we moved what we're publishing to this dist folder, we also needed to change our main entry there to say dist, because it's not the one in the root anymore. Sorry about that. I meant to do that. All right, so, and we're back. We've imported now. Our library gets the new compiled version rather than the original version, and it's all happy again. So, one quick note, normally you'd want to exclude your dist folder from Git, but I'm going to go ahead and include that in here so that you can kind of see the steps that we went through along the way. All right, so that's the very basic conversion that Babel does. And from here on out, we're going to skip out of our Node app and go ahead and move into a React component. So let me get rid of this distributed thing and everything we've got here. So since we're making a component library, let's go ahead and make a components folder. Oops. And what the component does for this demo is not really important, so I'm just going to make something really dead simple here. Sure. Yeah, it's npm check updates, and it just reads through your package JSON and finds one that there's newer. The -u flag says go ahead and update, and then we reinstall. So just a quicker way than having to manually edit the package file for this. So I don't want to spend a lot of time. We all know React here, so just do something super fast on this. So we'll have a component for a text input that's just going to take in a couple of props, the label, the value, and an onChange function. So we'll just print the label right before our input, say the value equals the value prop, if I could type, and onChange equals the onChange prop. We can go ahead and inline that too. So that's all the React we're going to do today. So go going back down here now, let's change our index file. We don't need any of our stuff in here anymore. So we're going to say import text input from components, text input, and we're going to export it under the name text input. All right, so let's try our build phase again, now that we have added some more stuff to it. And, oh, sorry, I meant to change package. And again, I'm going to gloss over running Babel manually just because we don't really need to do that. And we'll get to automating that in just a minute. So don't worry too much about what it's doing here, but geez, probably should have copy pasted this part too. Okay, so then our dist only has index, and sorry, the last try here ought to work. All right, the failure I was looking for. So Babel's trying to convert this JavaScript into the older style JavaScript, and it's coming through here and it runs into something that is not JavaScript, so it doesn't really know how to handle that. That's what I was mentioning about letting us use other things in there other than just newer versions of JavaScript. So we are going to add the @babel preset React. Back over here in our and you can use preset React, or they let you omit the preset. I don't know, personal preference. Either way works. So now when we try our build, the plugin knows how to handle React JSX, and we get new compiled output. So let's look what it did here now. So the way React actually works under the hood, all that JSX is kind of smoke and mirrors. What it's actually doing is calling just regular methods and returning regular old objects. So under the hood, we have, every time we have an opening angle bracket, React is calling create element and making, in this case, a div. This class, I'll make some more room if I can, creates the label. Somewhere over there is the input. So all the stuff that we had in our JSX has been turned into some really ugly JavaScript. But that's okay, because we don't have to work with it. We're going to work with our pretty compiled version all the time. So let's go ahead and push a new one up here. And install it in our React app. I'm being bitten again by my private repo. Since we only publish to the private repo, we need to install from the private repo. And again, that would be Artifactory or Nexus or something normally in a corporate environment. I took the liberty of going ahead and making our little app component pull in our text input component, and all it's doing is keeping track of what you typed with a little event handler and rendering our text input. So we will start this guy. I don't have to keep doing that 100 times. Let's say port equals 3040. Takes a minute. Blow this up a little bit, and we have our new component pulled in here. So it's got the label that we gave it, and the value there is getting updated as we type. So that's a very basic React component, and let's go ahead and make a commit. That's about as basic as it gets, and so far all we have are JavaScript files. So next, let's say that we wanted to style our input a little bit. So we have text input.cs. I'll go ahead and use Sass here, preference. Actually, I shouldn't need that. So text input, label, background color, red. Make it nice and tacky. That's all we need there. And I was mentioning experimental features. So this is not valid JavaScript either, but we're all used to doing it. Importing files that are not JavaScript requires some kind of plugin. You know, our own components that we're writing in our application and using something like Create React App, it's got, 50 different plugins already wired up for you, so we tend to overlook stuff like this. But this lets us import it in our application, but our library doesn't know how to compile that quite yet. So let's do our build phase again. And what we have in dist here didn't change very much, but it converted it into this require syntax of a Sass file. Let's bump our version and publish it. And oops, that's not the one I wanted. Can't find the right file. Everything's so big here. Okay, let's make a number 6. npm publish this guy and update our dependency over here. And sorry I'm moving fast, but I can't get this condensed down any shorter for our app here. So see what all this thing is doing and let it fire up once it's ready. Get our console up here because we are going to have an error. So our library now, we have a JavaScript file that's trying to require some CSS file. But Babel doesn't handle CSS files, so when it compiled it, we don't have our CSS file present. All we have is the JavaScript, because that's all Babel really does. It does have an option to copy some files, but at this point I want to move on to the concept of bundlers, which is going to make things a lot easier for us. So we won't have to run Babel manually anymore. And the bundler I'm going to use today is called rollup. So the two major ones you'll probably hear of are rollup and webpack. And while their distinctions gotten a little blurry over the years, a good rule of thumb is that webpack is for web applications and rollup is for library code. So I am going to cheat here again and pull in some dependencies. So we're going to install the rollup library, rollup plugin for Babel, and rollup plugin for CommonJS, and I'll show you why in just a second. And then finally a rollup plugin for dealing with CSS. Rollup hasn't fully gotten on the bandwagon of using the scopes yet. Hopefully they'll do that soon. In fact, the main rollup library itself is not in the scope either, but is what it is. So in the interest of time here, I am going to copy a file and just kind of walk through what's in it. So we're going to make a new file. Oh, I hate this bug. If you create a file when it doesn't have focus, it never can get focus back. Been in VS Code for a long time. All right, rollup.config.js, and we're going to plunk in a bunch of stuff here, and I'm just going to go over it quickly. So first we imported all of those plugins that we just installed. So there's one for Babel. So rollup is going to run Babel for us now, so we don't have to run it anymore by hand. There's a plugin for CommonJS because we want to compile to the CommonJS format. And then there's the plugin for CSS. And one thing to note here, if we compile everything to CommonJS, then we kind of lose the ability to use the ES module functionality. So generally, what most of the bigger packages do is they publish more than one output target. So we are going to start compiling our library into two different pieces. We're going to have one that is formatted as CommonJS, and we're going to have one that is formatted as an ES module. So this is literally just loading the package JSON file right next to it, and this main. So let's go ahead and give this a little bit better name. So we will say this is the CommonJS version. And then we are also going to publish a module version. And this is just NPM's syntax for this. So main is always going to be CommonJS format. Module is always going to be ES module format. And we'll create those two there. So then the plugins, we're just running through here. We set up Babel. I think this is actually the default. I don't think we need to explicitly do this, but I did nonetheless. And CommonJS format. You just include that plugin and then post CSS, and I'll talk about these two options in just a second. So Sass, we're going to switch to CSS, but let's go ahead and see what happens when we run rollup. So now, instead of running Babel, we are going to run rollup with -c says the config file. You can specify it, or if not, it'll go looking for this prefab pattern anyway. So npm run build. Make sure I'm in the right folder. That would help out a lot. We're not using Sass, but let's go ahead and do that too. So the node Sass is just command line Sass compiler. Anything that uses Sass generally uses that one, including the post CSS plugin that we did here, and it needs it because we said we're going to do Sass. Oh, we did actually already do Sass, so that's good. I would have needed it anyway. All right, so what rollup did for us here is create a dist now that has a handful of files. So it, first of all, bundled all of our stuff up into one big file, compiled it with Babel, and also ran it through the Sass compiler and the post CSS filter. So this is a lot like what Babel had for us. Puts it all in one file. This is the CommonJS format. And then in the ES module format, we actually have our more modern type of exports. That's good. So now whichever app we're including it in, if it's a React app, it will try to pull in the ES module version. But for instance, in your unit tests, it's going to try to pull in the CommonJS version. So now we offer both and let the user of our library pick. These map files are not human readable at all. They're just there for the Chrome debugger to show you what the original code looked like, so you're not trying to step through this in a debugger, which is kind of convenient. I want to really kind of hand wave over a couple of things with the Babel config now that we've got somebody else handling it for us. So back to our Babel config. We're using this env plugin, and we're going to add a couple of options to it. So what env is a plugin. Previously, when we wanted to compile an app and make it usable for older browsers, we had to go figure out what features were available in all of those browsers. And what did I do with my syntax here? That's what I broke. So we had to go figure out what features each of the browsers had. So figure out what IE's implemented yet, what Chrome's implemented, what Firefox, and so on and so forth. Babel env kind of does that for us. So it's picking out what environments that we need to compile for and picking out which features that we have that we're actually going to compile with. And to do a quick another build here with the debug output on, we will see that it did a lot of work for us. We would have had to plug in all of these different features to make it work in all of these different browsers. That's quite a lot there. There's 30 some odd other features. However, one other nice thing that we can do, if we don't tell it what we want to compile for, it is going to try to compile for the oldest possible thing that it could. A lot of us now want to just only support the newer browsers, so we can use a little trick here. Let me... Apologies, I forgot to copy paste something that I did there. So okay, so you might have seen this. Create React app will put this stuff in there for you. So we can use something very similar. Now we could do that in the Babel config itself, but the downside to that is if any other library wants it, it wouldn't find it and we'd have to copy paste stuff in there. So we can actually just drop this right in our package.json file. And I won't go into too much detail about the different things that it the different rules here. They're on its GitHub page, but so we can say, for instance, last one version, and it's gonna keep this live and up to date and figure out what the most recent versions that have been released for all the different browsers are. If we want to say, for instance, last 2 versions, we get, IE 10 and 11, Edge 81, 83, a bunch more of these here. Still a surprising number of people using BlackBerry, so we probably don't want to support some things like that. So that's what our not dead rule here is for, is any browser that's no longer supported gets kicked out of our list. We want to use it in Node as well, so maintained Node versions will add sorry, typo. That'll add some Node versions in here for us. And so let's do our build one more time and see what it changed the list to. Sorry, with the text this big, it's kind of hard to see, but this list is much shorter, and it's also telling us what features it used and for which browsers it included those for. Again, not real important, except that we don't want to have to manage this ourselves. So that browsers list pretty much takes care of it, and it'll stay up to date every time we compile. It will go out and look for the newest stats, and if we wanted to include IE, there's a whole bunch more stuff there, but if we're willing to kick IE out of the list of supported browsers, it shortens it by quite a lot. So there is that. Sorry, what's that? Because it doesn't work, and even Microsoft gave up on it. They started using Chrome, which was a shocker. I did forget to do this. I'm going to hand wave over this because we don't have a lot of time left. Core.js is a set of polyfills that adds older features back if and only if we need them in older browsers. I don't have time to dig into that much more. So there we go. We've got our browsers list set up. npm run build one more time. Do our version up one more time here. And split our windows again. And kick off our React app again. So let's see now if it actually worked. I did mention the post CSS extract here, so as soon as this thing finishes building, we'll see that pop up. And hopefully I didn't miss anything, and we'll have, once again, a working component here. All right, so I think this will about sum it up here. We've covered a lot, but there's two options with our post CSS now. So if we want CSS in our library, you can say extract true or extract false. Oddly enough, if you don't say anything, it doesn't do anything with the CSS. It's kind of odd. So let's try it real quick with the extract true option. So what that does is when it packages it up, it makes our JS file, but it also makes a CSS file. What this does is now when somebody else is including our app, if they are including our library, if they want to see the CSS, then they would have to import our CSS somewhere in their library. Not always a bad plan, but the path is a little bit weird. Library.cjss CSS. So they can include that somewhere high up like app here, and it'll kind of filter down through. So that's one way we could do it if we want to force them to include it explicitly. The other way, one reason this is bad, in our component we used a pretty generic class name, and especially if we just used something like button in the root scope, it would actually restyle every button in their app, and they would not like us very much. So the nicer option that we've got is the extract false option. And we're going to change just very slightly what we did with our component here. We're going to rename our SCSS file to .module.scss. And instead of a class name like this, we're going to switch over to camel case just to make life easier on this side. So now, instead of just importing it into the scope, we're actually going to assign our styles to a variable and then use that variable as the class that we get here. So now, if we run through our build one more time, we'll see something kind of neat that it does for us. Assuming that it, oh, changed my file name. CSS modules are kind of awesome. I didn't used to like them because they're kind of klutzy until I realized that you can combine them with Sass. So we really only have this one magic imported name. Everything else underneath could still use traditional CSS classes, which is kind of nice. But what it did for us now, since we said extract false, is in our compiled output, it added a function called inject CSS, which is going to on the fly go up to the document in the head and inject some styles for us. But because we're using CSS modules, it took our little fairly generic name here and put some random stuff to make it exclusive, as well as the name of our component. So now, if the app that's using this has something else called text input, they don't have to worry that our styles are going to clash with theirs. Got some unique output there. And the styles are directly inlined right here in the JavaScript file. So they get inserted in the document in the head just like they would, and they don't have to import that anymore. They're just going to import our library, and this happens in the process of that. So let's bump our version one last time and go see what happened on the React side. One last thing I forgot just to mention here. In the configuration, there's this thing called external. And what that is for is our library is using React, but we haven't really said that we're using React. So that's what peer dependencies are for. So anything I put in dependencies is going to get compiled into my library. So if there's something that I'm expecting the user that's going to use this library to already have, we put it in peer dependencies so that we don't end up with a whole second copy. So in this case, we've got things like React, and React always comes with React DOM. Now, unlike in our normal dependencies, we're not trying to go bleeding edge here. We actually want to go as old of a version as we think would work, because that way we're not forcing them to update just to get our library. And we know that our library will work just fine with older versions of React. So just a note there, your dev dependencies would have the bleeding one if you're going to run that, but what you force your users to have should be as permissive as possible. So our rollup config here is saying these things are external. So in short, rollup's going to just compile those a little bit differently the way it refers to them in there. The details of that are kind of not important, but just to note, any of your peer dependencies need to be copied into this array. Or since we're already reading our package file, we can just say, give me the keys from peer dependencies, and that way anything I add in there will automatically get adjusted. So we don't need this guy anymore. I forgot that step. Sorry, going quick here. So npm run build one last time. It gets rid of a warning that we had spitting out here. It was actually kind of trying to warn us that we didn't have a peer dependency, even though we referred to it. External tells it to ignore those. All right, and finally, fingers crossed. And I am quite disappointed in what didn't happen here, because it's supposed to be red right now. What did I do? I just did this in my test and it worked fine. Sorry. If this doesn't work, I will fix it before I push this commit, so that we have it up there. Yeah, and that's, you know, the post CSS plugin is taking care of it for us, and for the most part. But clearly I missed something, and I don't remember what. I just wanted to point out that it did, in fact, put that stuff up on the top of the page, so come on. All right, so we've got some CSS injected here. So I'll figure out why label didn't work. That is supposed to work. You know, you'll have your magic name on the top level component, but then you can use really generic stuff inside and refer to it that way. So then you only have to import and get this one big ugly thing. And this makes sure it won't clash with their code. So that is about it. Yeah, and Webpack has added some support for doing modules now as well. I've just gotten more comfortable with rollup, and initially they were designed to where rollup was for libraries. And Webpack won't compile like libraries that you want to make if you want to make one for Node.js or want to make one for a command line application or something like that. So that's kind of convenient that rollup is made to handle all those things. So in summary, we don't have really a lot of configuration here. You'll see a lot of articles out there that have, you know, tons and tons of different things included and 50 different plugins and different files all over the place. But modern tools make it pretty easy. Babel should keep us from having to import any kind of features that are accepted parts of the language. I don't really have time to touch on it much. I can copy paste one last thing here. But at any rate, the Babel config is being, or the Babel configuration is just a file. Rollup runs Babel for us, and everybody's happy. I didn't have time to get to it, but plugins here, when I was saying that we can use experimental features, some things that we're used to using in day-to-day world with create React app, we don't actually have. So like inside of a class body where you have whatever equals an arrow function, that's not actually officially supported syntax, so we can patch that in. And this syntax that looks like, I use this a lot. So one line here to re-export something that's not fully supported yet, but it is working its way up in the proposal process, and someday it'll get accepted and we'll take this out. Fortunately, Babel doesn't warn us about that, so I'm hoping they'll do something to address that later. But if you want other features of the language that aren't part of it yet, this is where they get added. Rollup config, real simple, just what's input, what do we want to output, and then just a couple of plugins to set all that up.